In this screencast, I'm going to export some data I have in a spreadsheet to a plain text format. I'm going to manipulate this data at the command line. I'm going to perform some simple statistics and then plot the results. So first of all, I'm going to open the spreadsheet I have with the data in. And this is just a spreadsheet with the atomic compositions of the amino acid side chains. So I'll save this in a plain text format. I'll choose the comma separated value. That changes the line ending to CSV. Now I can open this spreadsheet in Vim to see what it looks like. And you can see it doesn't quite look like what you might expect because there are these, the line endings are these M characters. But I can replace these to make it look more as it might expect. So now I have basically the same data where the name of the amino acid and each value is separated by a comma. And I can just align that data to make it show what the columns, how the columns look like. So now I want to manipulate this spreadsheet at the command line. So imagine this this data I have was very large and I wanted to find all the entries related to cysteine. I could use grep to do that and look for the phrase cis in amino acid CSV. And that shows me the entry for cysteine. Not only could I be searching a large file, but the entry for cysteine, I might not know which file it is, so I could search an entire directory just for the record containing cysteine. So that's why having data in a plain text format is quite useful. Next, I want to find the amino acid with the most number of carbon atoms in the side chain. I use awk for that. And the data is separated by comma, so I say -f, comma, and I write my awk code in here. So first of all, I'll print out the second column, which relates to carbon content, the amino acid CSV file. I can see this is the column for carbon atoms. That's not very useful on its own, so I'll also print out the name of the amino acid with it, which is in the first column. That's $1. So here I now have carbon content and name of the amino acid. I want to sort these, so I can output the results from this command into the sort command using the pipe, which is the vertical line here. And the command I want is sort-r to reverse sort. So you can now see the data is sorted by carbon content. And now finally I just want to see the first few entries, so I'll pipe the results of that into head with to show -n means show the first 6 lines of the results of sort. And so there I can see that tryptophan is the amino acid with 9 carbon atoms and the most. So that's a rather contrived example. However, I might want to also find some statistics about my data, and R is good for that, so I'd load R with the R command. Now R likes CSV format data. I can use the read.csv command for my file, which is aminoacids.csv, and that should load in my data. I can just write that and that shows me my data. It's quite large, so again I can use R's version of head just to show the top few lines. So now if I want to, I could get some summary statistics about the data, and that is summary data, and that just shows me some statistics about all the data. So for this, for example, in the carbon column, it shows me the mean, minimum value, first quartile, median, mean, etc. And I've got that data for all the columns, which is quite handy. But if I'm interested in individual columns, I can just do data $carbon, and that shows me the data, the values for carbon, and I can, if I want to, I can get the mean for that data, which is 3.3. So there's lots of commands you can do on vectors of data like that. I might also be interested in plotting that data. So I do plot a histogram, again, the carbon data. And that gives me a histogram. I might also want to plot the carbon data versus the hydrogen data. Which again gives me another plot. So that's great, but what happens if, so these are in a window, but what happens if I want image files of the data? I can just create a short R script to plot the image files. So edit a plot.r. So again, I'll just put the same commands in again. Data equals read CSV amino acids. That reads in the data. Then I want a histogram of the carbon data. And I want to plot carbon versus hydrogen. Now that won't give me image files. I need to specify the image files I want to print out. So I want to print PNG image format. And I'll call this one carbon.png, and I'll call the one below carbon hydrogen.png. And so those commands there just say print, set the device to PNG of a file name, either carbon.png or carbon hydrogen.png, and then print the resulting plot to that file. I just need to turn graphics off after doing that. So fingers crossed, if I run that command with R now, so I use R slave, my file is plot. Hopefully that should generate the files I want. Yeah, so I've got carbon PNG, carbon hydrogen PNG, so I can open those. That's my carbon file, got a carbon histogram, and carbon hydrogen gives me the plot I made earlier. So now what happens if I wanted to change some of these images? Say for example, I wanted to change the number of hydrogen atoms in Perlin. Say I got this wrong and I think there's actually 5 rather than 6 in the side chain. So replace that with 5. And I might also want to change the legends of the carbon hydrogen plot. So I'll just open that there and I'll just say the x-axis label is carbon atoms and the y-axis label is hydrogen atoms. If I run that R script again, open the carbon hydrogen plot, you can see that it has the updated legends here, and it's also replotted the data. So that's it. I wanted to just basically show how relatively simple and easy it is to manipulate data on the command line, and then using R you can also get simple and statistics and plots from the data as well.